All right, today we're going to talk about rational numbers. Rational numbers are different than integers because rational numbers include integers. So integers are considered a rational number. However, rational numbers are not considered an integer. Kind of like how squares are considered rectangles, but rectangles are not considered squares because rectangles have more specific traits than a square does. Rational numbers are integers like 1 to 30,000, and then all those also non-integer numbers that we've been not dealing with, like fractions and decimals. Sorry, this is going to be a mess trying to fit this in. Fractions and decimals. Okay, just like integers, these fractions and decimals can be positive or negative. So rational numbers are positive and negative fractions and decimals. They also include integers, which are positive and negative whole numbers. Some examples of some rational numbers can be found on this number line right here. Notice the positive ones are going to get plotted like right where you would think, like 3.4 would be almost right in the middle of 3 and 4. Whereas if we had negative 3.4, same thing, it would get plotted over here. Negative 3.5 is going to be in between negative 3 and negative 4. Negative 2.25 would just be a little bit after negative 2, getting a little bit smaller because as negative values get larger, they get smaller in value. Some skills that we might have to do with rational numbers is comparing and ordering them. And let's just remember, the more negative a number is, the less value it has. So the more negative a number is, the less value it has. Okay, so for example, we've got 1/7 and 4/7. 1/7 is a smaller value positive. 4/7 is a larger value when it's positive. Therefore, if we were to put these on the number line, negative 4/7 would be more negative, meaning it would have a smaller value than negative 1/7. Negative 1/7 would be closer to 0. The numbers that are closer to 0 have more value when they are negative. Negative 1 6/10, negative 1 3/10. Negative 1 3/10 would be closer to 0. It would be smaller if it was positive, therefore it's less negative, meaning that it has more value. When we have different denominators, so these were easy to compare because they both were sevenths, they both were tenths. When they have different denominators, we just have to make a common denominator. So we look to our smaller number. Can we make a 3 into a 6? Yes, times 2. We would do the same thing to the top. This would become negative 1 and 4/6. So now we're comparing negative 1 and 4/6 to negative 1 and 5/6. I'm just going to erase that real quick so I have room to write it. 4/6 and 5/6. 4/6 would be less negative, therefore it would be a larger value. 5/6 would be more negative, therefore it's a smaller value. Decimals are easier to compare because they're more similar to like a whole number. So we think about which one of these numbers would be closer to 0. That would be 2.5. So that's going to have a larger value at negative 2.5. You can think of temperature. Negative 2.7 is going to be colder than negative 2.5 because it's more negative. Therefore, it's a smaller value if it's colder. 1.3 and 1.34. When we have a number that has two numbers after the decimal and one that only has one, we have to fill in that next space, which is always just going to be a 0. So now we're comparing 1.30 and 1.34. Notice how they are both positive. So we're just comparing their normal values. Therefore, 1.34 would be larger. If you had $1.34, you'd have more money than if you had $1.30. Same thing here. We've got a number with 2 decimals, so we need to add that second decimal 0. Here they are negative. So we are looking for the larger value, meaning the warmer temperature, the smaller negative, that's going to be negative 2.60. Negative 2.62 would be colder than negative 2.60. All right, last but not least, we are ordering numbers from least to greatest. So we're looking for the most negative number first. The most negative number, we've got -1, -2.7, -2.5. Most negative would be -2.7. Then we've got -2.5 or -1. That would be -2.5, then -1. Now, as we're looking at our positives, we've got 0, 1.3, and 1.5. First would be 0. That would be our smallest positive. Then we have to compare between 1.3 and 1.5. Well, 1.5, if you're thinking of money, is 1.5 or 1.50. So the next smaller number between 1.5 and 1.3, excuse me, would be 1.3, then 1.5, or 1 and 1/2. Whichever number you'd want to put in your list is fine. Okay, so that's how we would compare and order rational numbers. Next thing we're going to have to do is graph them. So graphing, these are all starting positive, graphing 3/4. Well, if we were to count by fourths, it'd be like 1/4, 2/4, 3/4. That would be right about here. We put a nice big dot, and then we label it with the number 3/4. 1 and 1/3 would be after the 1, and then if we cut that into thirds, it'd be the first third, which should be like right about here. It does not have to be perfect, but it has to be right around. Like, for example, 3/4 is more than half, so if you put 3/4 over here, that would not work because it would be closer to the 1 than to the 0. Then we've got 2.5, so we'd have to extend this line so it go into 3, and then we'd put 2.5 right in the middle. And then just regular 1/2 would be right before 3/4, in between 0 and 1. So just like when we are graphing positive fractions on the number line, we do the same thing but in the opposite direction when we're doing negatives. We also will have to graph decimals because rational numbers are also decimals. So let's think about 0.3 would be closer to 0 than 1. It would be like right around here because if we counted by tenths, it would be 3/10. So this would be right about where 0.3 is. 1.6 would be a little bit over half between 1 and 2. 2.1 would just be a little bit after 2. 0.75. Well, we've got 0.3. 0.75 is more than double that. It's closer to 1. So I would put that right about here. 0.75. Okay. Same idea when they are negative. So if I have -4/5, if it was +4/5, I would graph it right around here because if I cut it into fifths, I'd have to count 1, 2, 3, 4/5 right here. Well, it's going to mirror that on the other side. So if you ever want to like graph a negative number, think about where the positive number would go, and then it would basically just get flipped over to that other side. Think about if we counted by fifths here, it'd be 1/5, 2/5, 3/5, 4/5, 5/5. So -4/5 would be right about here. We've got -1 and 1/3. Well, if we graphed 1 and 1/3, it would be right about here, in between the 1 and 2, closer to the 1. Same thing, in between the 1 and 2, closer to the 1, because it's 1 and 1/3, not 1 and 2/3. -1 and 1/3. Last, we've got -2.5. If this was positive, it would be halfway between that 2 and that 3. So just add in a 3. -2.5 would be right in the middle. Oh, sorry, it's supposed to be a fraction, not a decimal. -2.5. Okay, same thing with decimals. -0.2. So if I would think about positive 0.2, that would be right about here. So I'm just going to go that same distance away from 0 and graph it right here. Then I've got -1.8. Well, if that was positive, it'd be in between 1 and 2, and it'd be closer to 2 because 1.8 is pretty close to 2. So same thing with -1.8 is going to be in between -1 and -2, closer to that 2, I would say right about here. Negative 2.2 would be past negative 2 just a little bit. Negative 2.6 would be past 2 even more. And negative 0.9, I'm going to go back to thinking about a positive. 0.9 would be really, really close to that 1, but not quite there. So negative 0.9 is going to be really, really close to that negative 1, but not quite there. Okay. Then on some graphs, you might have to graph fractions and decimals on the same graph. You're going to do the exact same thing. You're going to do your best of estimating where that goes. So negative 3/5. Negative 3/5 is more than half. So we're going to put it like right about here, in between 0 and 1. Negative 1.6 is a little bit more than halfway in between negative 1 and 2. So I'm going to put that one right here. Positive 2.1 is going to be just a little bit after positive 2. Negative 1.78. So here we've got a negative 1.7 and a negative 1.6. 1.7 is going to be closer to 2 than 1.6 is. So when we put in that negative 1.78, we have to make sure that it's closer to the 2 than the 1.6 is. Then we have a positive half, halfway between 0 and 1, and a positive 3/4, which is just a little bit closer to 1, in between 0 and 1. And that's how we're going to compare, order, and graph rational numbers.